Welcome to Neural Engineering Research at CWRU. This is a short video to show you some of the facilities that we offer for our students in research. Neural engineering research takes place mostly at the Neural Engineering Center, for which I'm the director. That center is located in the Wickenden building on the campus of CWRU. However, many students work in the various hospitals around campus, such as the Cleveland Clinic or Metro hospitals, university hospitals, or the VA hospital. Students work in many areas of neural engineering, such as neural interfacing, neuroprosthetics, neuromodulation, neuroimaging, neuromodeling, etc. They work with patients with various conditions such as paralysis, epilepsy, stroke, Alzheimer's, or Parkinson's disease. But also many students work with animals. The center offers many facilities right here in the Wickenden building, such as a surgical suite, a small animal facility for imaging animals, transgenic mice or rodents. We have a small bore MRI machines. Microscopy is available, and electrophysiology laboratory is also available. For the rest of this video, you'll see some of these facilities, and I encourage you to check out the video that you're seeing on your screen right now for the Neural Engineering website.
All right, hello everyone, my name is Joseph Marmerstein. I'm a fifth-year PhD student in Dr. Durand's lab here at the NEC at Case Western Reserve University. So we're going to give a quick tour of some of our facilities here. So this is the Neural Engineering Center located on the first floor of Wickenden. This is what we call the Bullpen. It's sort of a big open area where all the students as well as professors have their desks. So we got multiple rows here with students sort of interspersed with different labs. So it's really easy to collaborate with both your lab mates as well as people in other labs. And if we just turn and sort of walk down the hall here, there's professors' offices that line sort of the walls of this area, and then multiple rows of desks of students. And then if we continue down the hall, we will then eventually go to the area where all of the lab spaces are, just down here. So again, more desks. There's another sort of office area back there. We've got a little break room with the kitchen. And then down the hall here is where all of the lab spaces are for the NEC labs. And if we go all the way down to the end of the hall, we're going to get to my lab, Dr. Durand's lab, that we'll get to in just a minute. So just going to give you a quick tour. This lab space that we're in right now is shared by Dr. Durand's two labs. He runs one lab that focuses on the peripheral nervous system and one lab that focuses on the central nervous system. And again, this space is shared by both. So we're just going to give a quick go around. So in this area here, we have a soldering station. We do a lot of our electronics building, designing our boards, amplifier boards, everything that we use to do our chronic recordings in animals. If we keep going a little bit further, this corner is where we do manufacturing of our electrodes. So we use carbon nanotube yarn electrodes for chronic recording in peripheral nerves in animals. And so we've got sort of our storage over here on a air buffered table, and a microscope and a lot of other materials that we use to build the electronics for implantation over here. If we keep circling around this way, we've got a station here that's used for recording and stimulating in brain slices, rodent brain slices. So there's temperature controlled baths and microscope and everything that you can use to conduct those recordings. We can keep going. We've got a chemical fume hood over here, and then another recording station over in the corner here. So pretty sort of big space that we use for a lot of different things, mostly conducting some experiments here and then preparing our materials to conduct our animal experiments, which we'll show you when we move over to the animal facility in this same building on the same floor. All right, so we're here in the Wickenden Animal Facility. So we are lucky enough here at Case to have a small satellite facility for housing mice and rats here in the building on the same floor where our desks are, where we can do our work. It makes it very easy to just be able to walk down the hall and do our experiments, do our surgeries, and it's very helpful. It's a big sort of shared space, so all the labs that are doing experiments with mice and rats are using this space at different times. So we have a few different surgical tables, different areas. So this first surgical area here is primarily used by Dr. Durand's lab. So we do rat and mouse surgeries here, as well as some of our recordings and other experiments that we do with the animals. Over here in the middle area, we have another surgical area that's primarily used by Dr. Capadona and Dr. Schaafstall's labs. And then over in the far side, we have another surgical area that's primarily used also by Dr. Durand's lab for implanting of brain electrodes in rats for recording EEG from the brain. So that gives you sort of an overview of what the facility is like here. Again, the big benefit is that we don't have to walk all the way across campus to do our experiments. We can do them all right here in-house. Makes it a lot easier as well to monitor the animals. And next I'm going to kick it over to Peter, who's going to tell you about our MRI machine that we also have on this floor.
Hi everyone, my name is Peter Chow. I am a graduate student in Jung Lu's lab. We like to just call him ZR. And today I'll be showing you our new 3 Tesla MRI system. Let's go take a look. So the first thing that we need to do is make sure we're MRI safe. There's a strong magnetic field, so I've already done that. Come on in. So this is our 3 Tesla MRI system. It was installed in 2000 and I want to say the end of 2018, so it's about a year and some change old. This is basically one of the few MRI scanners, not only on campus but in the world, that we can use for scanning mice. There's another system in Stanford, and then there's a couple of systems at WashU and some others across the world, but we're lucky to have one of the only ones here in Cleveland. This MRI scanner is capable of scanning mice and rats and all other small animals, and we can do the same kind of scans you would find in a hospital. So fast spin echo is a very common pulse sequence used clinically, and we can do that here, but we can also do more advanced scans such as T1 mapping, T2 mapping, diffusion weighted imaging, and others that you may have hopefully read about in a paper or seen in a lecture or seminar somewhere. So it's really exciting stuff. If you come over here, I can show you our kind of surgical setup. So this is, it's a little bit kind of clean right now and like not being used, but this is where we would traditionally have a mouse and do IV injections and surgical procedures with our anesthesia. Coming around to here, we have the actual bore of the scanner. Excuse me, I have to glove up. Safety is job one. Pull this out. This is what the MRI scanner looks like. So the mouse would go here. This is our RF coil that both transmits and receives. The main magnet, of course, does not move. And then all of this is to keep the mouse warm and anesthetized and calm, along with our MRI compatible animal monitoring system, so we can monitor vital signs during the scan. This slides right in there. And last but not least, of course, with any MRI scanner, you've got to have some brains. And we have brains aplenty. This is the MR Solutions Evo spectrometer with all of the power supplies and circuits and amplifiers that make our system work. So I spend a lot of time maintaining and otherwise kind of ensuring that the MRI system is working at peak capacity. So this is kind of my home. All right, and I guess that's it for the 3 Tesla MRI system. I hope you guys enjoyed seeing a small slice of what we do here at Case.